Welcome to Formtek's podcast on pre-cut versus post-cut. This is a common question that we received quite often through our customers and talking to either through quotes or at trade shows. Before we get going, I'd like to first define what it is that we mean by pre-cut versus post-cut. Pre-cut, we're feeding a roll former a pre-cut blank that has a specific length. Post-cut, we're essentially cutting the length after we roll form the part. And we're going to show the two types of lines for our listeners to the podcast. If you want to look at our YouTube video, you can pick that up later. But basically, we're going to show you the two different diagrams. Now, there's a few versions of how these lines can be arranged, but generically speaking, a pre-cut line, you're going to have either hand-fed blanks or you have an uncoiler with a pre-cut type of device, either a press or some other device that is cutting the strips, feeding it into the roll former. With a post-cut line, we have an uncoiler that we're feeding off a coil into the roll former, and then we're cutting with a specific type of press after we roll form. So the big question here that we often get, and I'm going to start with Paul on my left, and I have Darren on my right. I'm going to start with Paul, that one of the big things we get is, which one do I use? Why would one company want to consider one versus the other?
Well, so typically what we talk about in general is that the further you get away from the uncoiler, the punching or the cutting tooling gets more expensive. So,
Right.
so typically in
Okay.
a pre-cut system, just in regards to the tooling system, you may have a simple shear that you're going to have to use and require.
And you're saying a shear with a flat strip.
A flat strip shear, okay. If you have multiple sizes of a certain shape that you're going to run that we're able to do in the roll former, a flat shear may be the easier way to go ahead and achieve that than a post-cut system where you may have to change out inserts in the post-cut-off system.
So it's a cost advantage.
It could be, absolutely.
That's good. Any other reasons?
Well, so if we do a flying pre-cut system where we have a die that's flying right before the roll former, the overall line space is about the same compared to a post-cut system. But if for some reason we need to run it off where we stationary cut and we have to go into a conveyor system that goes into the roll former, now that line layout could be a little bit longer and it may be a space issue in the size of the plant. So that comes into play of looking at what we have to do, and depending on the operation that needs to also do. If there's some kind of punching or some type of feature that's in the profile, at least from the punching aspect, if we have to do some kind of shear form or something like that, and now that we have to clear the rolls out all the way through the roll former, it may not be advantageous to go ahead and do a pre-cut. So some of it comes into the length of the parts that we have to do as well. If they're short parts, we can only go 3 stands of the horizontals to be able to do those lengths. So.
And you're kind of leading us right into what I was going to ask Darren about some of the roll forming aspects. What do we talk about when we're doing pre-cut versus post-cut? What do we do different in the roll former?
Well, usually in the roll former, if you're running pre-cut, you end up having more forming stations, right? It's usually, the rule of thumb is 25% more forming stations than if you would run from coil. And that's because as you form the part, you can't move it as quickly, and it will want to open as it goes into each station. So it takes more of it to take a set to minimize flare. The other side of it, what Paul alluded to, is part length. If you have long parts, it's not a question. But it really comes down to what's your shortest part is the issue. Longer parts, you just need more space on the front end. The smallest part, you have to be in, 2 driven stands at any given time. So like Paul said, 3 horizontal centers of your machine is usually the minimum requirement. Are there ways around that? Sure, there's creative ways you can do. You can make tab parts so that you can essentially run a longer part through, break it off, and then you get the 2 parts that you need. There are tricks that you can do, but in general, most people can't live with that because you'll have little dimples on the end, right? If you tabbed it, but some people can. It just depends on the application. And also the other thing that determines pre-cut versus post-cut, and I think Paul will probably touch a little more on it, is can you even cut the part off in a reasonable way without adding a bunch of pre-notching or other things? So your part itself may dictate pre-cut versus post-cut. For example, if you look at
The part geometry.
yeah, if you look at box shelving, that's always pre-cut. I don't know of any box shelf line that's a post-cut
Okay.
because of the width of the part and the geometry of the part.
You know, one of the things that brings up a good point is we talk about is when we do our presentations at any of the trade shows or the roll forming conferences, or when we have one-on-one meetings with the customers, I call it what's the shape of the problem? So alluding to that, what is the shape? Because that determines what that cost of a post cut could be compared to something we could do with a pre-cut. A downside with the pre-cut is obviously we have more stands to try to eliminate some of the flare, but tends to be more flare than in a post-cut system.
Right.
If we're pre-notching something in a pre-cut system, it's usually better to have it where we have a post-cut system that we have control of it through the whole roll former. Okay, even though we're in the 3 stands or anything else, it tends to make those notches a little bit bigger, better, I should say. You know,
All right.
so.
And typically your throughput is greater on a post-cut than it is pre-cut, because pre-cut, you're pulling gaps between the parts. So sure, your
Good
mill's
point.
running at 80 feet a minute, but you're not getting 80 feet a minute worth
Right.
of
You're
product
only
on the
getting
end.
so many parts out per minute.
So if there's whatever that gap is, you're talking it could be up to 30 or 40% less.
Sure.
You know,
Well, another thing that comes into play with the pre-cut is that if a customer doesn't want to spend the money for a whole front end line of an uncoiler, things like that, feeder system, and their lengths are not 20-foot lengths where they have to take a 20-foot strip and run them through, right? They can take smaller lengths, just hand feed them into the roll former and start off into the roll forming compared to coming, say, from a press brake operation or something like that. It's initially to get into roll forming.
That's true.
Another thing in regards to no matter what, pre-cut or post-cut, there is going to be some kind of flare or distortion in the part. So when we pre-cut, we're going to see it flare out and toe in. Okay, you'll see the same on a post-cut system, but
Just less of it.
you typically, if you don't have enough passes in the roll former, no matter which way, you're still going to see that type of a flare.
And we've mentioned flare several times. We're going to put up a diagram for our viewers that kind of shows a part with flare, and essentially it's a distortion of the profile. What you're essentially damaging the lead end and the tail end of the part because we're not controlling it in the same manner continuously like we would from coil.
but put it into perspective of how much flare you're talking about, because you're
That's true.
saying you're damaging the part. You're not damaging the part.
You're
It's
not damaging the part.
It's just not taking a set. And then, so the front end is leading, so that's always going in. The tail end's going for a ride, so that's just not. There's nothing after that edge to
That it
keep to,
springs
so,
open.
So it springs open, and flare can be, anywhere. We've had it as minimal as 15 thou. But you can have up to 80 thou, right?
Easily.
Yeah, easily. And it just depends. Now, are there ways to minimize that? There's things you can put in there to help reduce it.
To reduce it. Like
But
you
it's
said,
never
25% more
it's
passes.
just never, ever, ever going to be zero.
Right. When you mentioned 25% more passes,
Right.
we're slowing the forming down
Right.
to help improve
Help it take a set.
or minimize the flare characteristics.
And you
What kind of-
actually design your rolls differently a little bit if you're designing for pre-cut versus post-cut, because you have to have flanges and other things that make sure it leads in. Your roll configuration will be different if you were doing a post-cut operation. So, because you want to be able to pick that part up and get it into the next pass. Where if anybody's running coil and you ever see a guy threading the machine and he's using his hand to bump the part into the next one, he's kind of guiding it. In a pre-cut operation, nobody can reach in there and touch it, right? You got to be safe. You can't reach in there. So it takes a little bit more thought and doing you have to design for pre-cut.
You have to design for the pre-cut. And basically, where would be a situation, what kind of parts that you would consider you really can't have this kind of flare? Because we mentioned you have toe in at the beginning, flare out, or toe out at the end. One part that comes to my mind is we've had customers where they've taken light fixtures and they want to butt them up end for end to make 2 4-footers to make an 8-footer. That's really difficult with flare. Is there any other products that you can think of that
Refrigerator skins?
Okay.
You think you got the sides, the top, and the 2 sides and the top. That's all one piece that's bent. I mean, the refrigerator skin and where those corners are. I mean, but there's just like when we did that refrigerator line for Mexico, there's a way to have when it folds up so it minimizes the view of that. Right? We created how we tabbed it and offset.
Absolutely.
So there's ways they can do it. And it may be a case where when they fold it up and you have that overlap so it covers, they may have a secondary process where they're toggle locking that, right? So the flare, yes, they want it minimized, but as long as it's not gross, it won't matter. So it just depends on the application.
Yeah, I could think of refrigeration mullions, some office products, partitions, things like that, ball bearing drawer slides. While a lot of them are small, there are longer ones you'd never want to go ahead and try to do a pre-cut and stuff like that. But another thing too that comes to mind is that anytime we're pre-cutting or post-cutting and we have any punching, depending on the amount of stands, if the roll tooling is not designed correctly or we don't have enough stands or the type of machine is selected incorrectly, can affect the type of notches and things like that, the features in the product. We did see, like in an office partition, where typically the tolerance they go from 12 inches to 84 inches, let's say, and the first to last slot has to be plus or minus 15 to the total. Okay, like it's not cumulative. We did see with enough passes, where we had a 32 pass welded mill with a welded system at the back end, where we saw no stretch. Because we had so many passes, they were repurposing a mill. So while it isn't typically cost effective to throw in a whole nother roll former or doubling the amount of passes, there is ways to do that if it is really that crucial, to more passes, bring up the part a lot slower to help minimize some of that.
You touched on welding, and to me that's another process that really does not like pre-cut at all.
You're right.
Because of the flare, it has to be. It doesn't absolutely have to be, but 99% of the time it is continuous.
Right.
But that's very interesting to know. So we've kind of talked about the pre-cut, post-cut. It doesn't sound like there's one process that's better than the other. What do you think?
Other than the super mill, I don't know any pre-cut machines that are running over 200 feet a minute. I mean, the super mill runs at 500.
Yeah,
but that's a very specific application. Construction products, making metal studs, right? I mean, we're the only ones that do it pre-cut. Everybody else is doing it post.
And one thing, with going to that about line speed is just because, as you mentioned, say 200 feet a minute, right? So that's a great number. Just because the mill is doing 200 feet per minute in a pre-cut situation doesn't mean the actual throughput is there, because we're not able to hit some of that in a start and stop with a stationary shear or some type of cutting for the pre-cut, or even a flying one. And with the gap that Darren mentioned before, that throughput is not the same as if we were in a post-cut. Now we're running complete 200 feet per minute, let's say, and now our post-cut system is timed out for that, and that's a true throughput of that. So that actually does come into play a little bit.
All right, so we've also touched on the production rates. You got to really calculate it correctly if you're looking at pre-cut versus it's a little easier with post-cut, right, because it's constantly running.
And operators too, unless you have an automatic destack system, or if you're doing pre-cut and you have a destacking system, that's going to load the parts and send them down automatically. But if you had otherwise, on a pre-cut, you have 2 operators. You got a guy feeding and a guy catching.
If you don't have some kind of flying shear,
if you don't have
or coming from coil,
right? If you're not coming from coil, if you're just using blanks, So, you got to look at it from the operator standpoint, where if it's a coil run line, you could really get away with one operator if it's from coil. So you consider that part.
What happens if I had a pre-cut line in my operation and I want to change it to a post-cut? It sounds like it should be an easy thing, or an easier process.
Yeah, it's an easier process because you already have more passes. The only thing is like you said, is if the geometry is prohibitive.
Yeah, and like I was mentioning, so doing a pre-cut system with a standalone mill, can get you into becoming a roll former.
Kind of by steps.
Right. So this way you already have the machine now. It's easy to add the front end uncoil or straighter feed or whatever you have to do with that, or the post process of a press and a die.
I mean, I'll say in general, a roll forming operation only consumes, if you look at the total cost of the part, is only about 7%. That's what is a rule of thumb. So if you look at your material cost and your direct labor cost to that, material cost is the bigger portion of it. Labor is a very small part of it because it's a very efficient process. Whereas if you take a press brake for instance, your throughput's so much greater in a roll former than it is a press brake. Labor becomes a bigger component of your total cost. So you have M and your L.
Okay.
So think about that.
Paul, you mentioned earlier, you were talking about the minimum length for a pre-cut and minimum length. Is there a minimum length for post-cut? Because that would seem like that's an advantage to me then. Post-cut, theoretically, you can cut a really 2-inch or 3-inch long part if that's what you needed.
Yep. So there's a couple of things to that. So it comes down to, usually with the roll forming process, we want to have it continuous. We don't want to start-stop, even with a post-cut system, right? We can do that, and can do simple 1-inch cuts or anything like that. But once again, it comes down to the throughput. Just because the roll mill speed can do something, you have to speed up, slow down, stop, and cut. So we're always looking to try to do something, and it's a continuous and on the fly. So it comes down to line speed and minimum part. So in general, when somebody asks me that, I said, well, easily I know I can do a 36-inch part at 150 feet a minute. And some of it's, the calculations are linear then. So 18 at 75, okay? 9 at 38, type of thing. And I could back up just quickly if somebody asks me that off the top of my head. Then comes in the type of die, depending on what we have to do, okay? And the stroke of the press. And that comes into play of my cycle time of presses and what kind of measuring system. And so there's other things that come along, but those are just in general. So we can go down.
We'll talk about those later.
Yeah, absolutely. But it goes into those, that comes all into a realm of things. So we can go ahead now. We're not bound by the 3 horizontals, even if it's a small inch mill, shaft mill, or we have close horizontals or far away. We're not limited to that minimum part.
Okay. Darren, another question. When you have tall parts that you're forming, pre-cut it's a little bit more difficult, is it not? Because not only do you got to fold these legs up, but you usually want to have really close centers for pre-cut because that would help with our minimum length. So sometimes we've seen customers ask us, hey, I want to form a 3 or 4 inch leg, but my minimum length is 2 feet, 24 inches. That's kind of tough because we're in a big roll former, right?
Yeah, so generally, if it's 1.5 degrees tangent, the horizontal, right? I mean, that was our usual calculation. Taller parts require larger horizontal centers. Otherwise you're going to need more stations and move it slower. So if you take something that, say it's a 6-inch leg, and you may do it in, say, 16 stations from coil, that 25%, depending on horizontals, could be 50% more stations if the centers are close. Again, it's just about grabbing that edge of paper and, moving it, looking at that distance that you're moving that edge. Because otherwise you stretch it and then you end up with more problems. Yeah, it's no different than in a pipe mill.
That's correct. All right, well, I think we've talked a lot about pre-cut versus post-cut. Please join us again on another Formtek podcast, and we'll talk to you later. Take care.